Hello everyone. So today's topic is Bitonic linked list. और अब आप ये सोच रहे होंगे कि Bitonic क्या होता है, linked list क्या होता है? ठीक है, linked list आपको पता होगा because you are studying data structures and algorithm from a long time. You might be practicing that also. Okay. Now the word Bitonic means that the data could be first monotonically increasing like 1, 2, 3, 4, 5, and then after a point of time, maybe now it's decreasing 8, 6, 7, something like that. Okay. And what you have to do in this question is that you will be given Bitonic data, Bitonic linked list. You have to sort the Bitonic linked list and then print the elements. So the output will be 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So let's dive into the code now. The most important सबसे पहले हमें यही करना होता है हर बार हमें static class node बनाना होता है. Okay, we have to create static class node. Then we have to make some features that is node next. Then doubly linked list है the node previous. Okay, and okay, wait a second. Over here I have written linked list. That means singly linked. So for the time being, I'll neglect this part, and after making the code for linked list, I'll tell you where you have to write just few lines, and this will convert from linked list to doubly linked list. Okay. Node next, and then हमें देना होगा int data value के लिए because a node has two features. Its element that is the data and it's pointing to next. So we can create a constructor over here. कंस्ट्रक्टर बनाएंगे हम यहाँ पे ऐसा करेंगे फिर यहाँ पे कर देंगे int data. Okay, now then we'll say simply this dot data equal to data, something like this. Okay, and this is the completion of our inner class. Now we'll be writing the main method, something of this sort, and then we will say we'll create object of scanner. We say scanner sc is equal to new scanner, and we'll say system dot it. Okay, usual as we do. Now we'll be asking user how many nodes are there. So we say intent is equal to sc dot next int. Okay, and then we will say okay, we know what are the elements, how many elements are there, but we have to fill it. So we have to create first pointer that is temporary. So we'll say let's say dummy is equal to new node, and let's put -1 over here. Okay, and another node will say node answer, and this would point to dummy itself. Okay, now you will understand this usual process once you get into the practice of linked list, doubly linked list. Okay, तो देखिए हमने ये क्यों किया. Now what next we'll do, we'll say for loop. We'll say int I is equal to 0, I less than n, I plus plus. ठीक है. Then what we'll say, we'll ask the user what is the element. sc dot next int. Okay, element हमें पता चल गया. अब हम एक node बनाएंगे. We create a node. Node is equal to new node. Okay, and then we'll put element over here. Now we have created a node. Now we have to point it. So to make the links, what we'll do, we'll say dummy dot next. अब आपको समझ आ रहा होगा why we have made dummy. Okay, dummy dot next equal to node, and then we will say dummy equal to dummy dot next. We move one step ahead. Okay, so this will create a linked list, singly linked list with the elements that the user has given. Okay, simple, sorted. ठीक है. अब क्या होगा, हमारी लिंक लिस्ट में एलिमेंट्स कैसे थे, पहले मोनोटोनिकली इंक्रीजिंग था, उसके बाद मोनोटोनिकली डिक्रीजिंग था. तो हम क्या करेंगे, वील फर्स्ट से आर हेड. ओके, तो हम एक हेड नोड बनाते हैं, हेड इक्वल टू व्हाट विल बी द हेड, हेड विल बी आंसर डॉट नेक्स्ट. यस यू गॉट राइट, बिकॉज डमी के पास क्या था, -1 था, तो -1 वाली नोट हमारी हेल्पर नोट थी बस. ठीक है, तो उसको हम आंसर नहीं लेंगे. दैट्स व्हाई वी हैव मेड आंसर पॉइंटेड टू डमी एंड देन वी से हेड इक्वल टू डमी डॉट. ओके, क्लियर. Next, we'll create node first equal to null and say node second equal to null. Okay. Then we'll create another helper node that is temporary. So node temp is equal to head, something like this. Okay. Now what we'll say, we have to check at a point where the node elements, that is to break the node, the linked list into two halves. To understand more linked list into part. So what we'll do, we'll use a for loop, while loop basically, and we'll check a condition. क्या करेंगे हम, we'll say while t not equal to null, that is temporary node, and then t dot next not equal to null. Okay, जब तक ऐसा है till then what we'll say t, sorry, s is equal to, f is equal to, first will be t and second will be pointing to t dot next. Okay, something like this, and then we say if at a point, if first dot data, okay, if first dot data is greater than second dot data. Okay, so you can see this will be that scenario when first dot data is greater than second dot data. Okay, so first will point to 8, second will point to 6. Then at this point, what we'll do two things. First will be BDLL equal to 2, and next will be take statement. Now what is BDLL? So BDLL will be taking a track. It will be a Boolean variable, Boolean BDLL or something like that, and we will put it initially false. Okay. तो अब ये क्या कर रहा है? ये एक ट्रैक रखना चाह रहा है कि क्या there is a linked list with elements only increasing or there is two halves. One is monolithic increasing, then is monolithic decreasing. ठीक है. So if that is true, that means we have found a monolithic decreasing half. Okay. Then we'll come out, and what will happen? First we'll point to A. So what we'll do? We'll say f dot next equal to none. So we are breaking the nodes into two halves. Okay, something like this. And then we'll say supposing node head 2 equal to s, something like this. Okay. Okay, fine. Now we have broken the linked list into two halves. First is the monolithic increasing part, then the next is the monolithic decreasing part. In this case, after these steps, what will happen? 1, 2, 3, 4, 5, and 8. This complete will be considered as left half and 6 will be considered as the right half. Okay. I think up tak ka clear hoga. It will be very clear. Okay. Now what we have to do? We have to, because the right half elements are in decreasing order. So the first step over here is that we have to reverse the elements in the second half. For that, we need a reverse function. What we'll do? We create a static node reverse linked list. Okay, then we'll pass node head. And here, for simplicity, for your easiness to remember or to understand this code, I'll creating a recursive code over here. ठीक. तो break किस क्या होगा? सबसे पहले break के साथ है हमारा. What we'll say is head equal to null. Okay, or head dot next equal to null. So in this case, what we'll say return head, because हमारी लिंक लिस्ट या तो एम्प्टी थी या हमारी लिंक लिस्ट में बस एक ही एलिमेंट था. तो उस केस में क्या हुआ? उस केस में we'll simply say that we don't have to reverse anything. The link list is already reversed because it has only one element, only one node or no node. Okay, that is the case. We'll do this. Otherwise, what we'll do? We'll take a node, our node equal to. We'll call the function itself. We'll say rev list. Then we'll say head dot next. It will work for rest of the half. Okay. Then we will see head dot next equal to head. Then we will say head dot next equal to null, and then we will say we are done with the work. We will return our node, and this is the code that will work for reversing the linked list. Okay, so now what we'll do? We'll create. Okay, simply what we can do instead of this, we can directly say rev list s. This becomes head 2, and for head 1, what we can do? Can edit this simply and write head 1 over there. Okay, and because we made head 1, we'll put head 1 over here also. Okay, I hope this is clear. Now we have reversed the linked list second half. Now we have to merge it. So for that we have to create a function again that will be called as merge. So it says static node merge, and this will have two parameters. First will be node say h1, that is head 1, and then node h2, that will be head 2. Okay, okay, simple. Now what we'll do? We'll say y h1 not equal to null and then h2 not equal to null. Then we have to do some work. But for that, again, we have to use the simple concept of dummy. तो यहाँ से कॉपी कर लेते हैं, हम यहाँ से कॉपी कर लेते हैं. Okay, and then we will put it over here as it is. Okay, simple. Now we will be checking the values. So if h1 dot data, okay, is less than h2 dot data, in this case h1 has a smaller element, so we have to connect dummy dot next equal to h1 and h1 equal to h1 dot next. So this is done. So we move it one step ahead. Okay. अगर ऐसा नहीं है तो opposite है, h2 वाला part छोटा है. So what will happen? Dummy dot next will point to h2 and h2 will move one step ahead. Okay, simple. And when everything is done, what will happen? We have to say dummy equal to dummy dot. Okay, dummy को भी move करना पड़ेगा. Okay, simple है. Okay. But there can be a scenario that some nodes are still left. So what will happen? Now we'll come out and we'll say while h1 not equal to null, ठीक है? So what we have to do? We'll again say dummy equal to h1 dot next and h1 is equal to h1 dot next. Okay, and next we'll say dummy equal to dummy dot next. Now, this can be a scenario with H2 also, that H2 hasn't reached the null point because this is the double AND condition. So if one of the condition is false, it will come out. And if another condition is not false, it was true at that time. That means some nodes elements have been left. So we have to check again. So we say H2 over here. Okay. Similarly, H2 over here, H2 and H2. Okay. When everything is done, what we have to return? Yes, you thought right. We will simply return answer dot next. Okay. Answer dot next. And we will write the return statement. Return answer. So this is the merge function code. Okay. So this would work. And it will give an answer node. Okay. So we can say node result or something like that. And then we can call it. We can call merge head 1 and head 2 semicolon. Okay. Everything is done. What we have to do now? We have to print value. So we can create a print method of it. Or we can simply traverse over errors. Okay. It's better we create a print method. Okay. So we'll create a print method. So we say static void print linked list, and it will have again a pointer called head because we traverse the linked list through the head itself. Okay. Now what we'll do, we'll say while head not equal to none, we'll come in, we'll say so ut, okay, I'll remove this, I'll say dot data plus, and I'll leave a space over. For your convenience and for your importance, please make a point, you have to write head equal to head dot next. क्योंकि अगर आप ऐसा नहीं करोगे तो क्या होगा? It will keep on running and trap in a for infinite loop. Okay, please make a short point. And remember this is the usual point जहाँ गलती आती है and then at the time of debug one by one then you find it. But जब कोड आपका इतना बड़ा हो 159, so it's better to take care at that time itself. Okay. Again, I found a point over here. I haven't done t equal to t dot next, so that will have an issue over here. So we have to do t equal to t dot next. Okay. Okay. Now that we have traversed everything, then we can call print list and we'll pass res index. Okay. Let's run this. Supposedly I give 5 elements. 1, 2, 3, 4, 5. Now there's a problem because this half only has the increasing element. So we have missed a check over here, that is the use of BDLL. Okay. So what we have to do over here, we have to say if not of BDLL, that means it is false. Then what we have to say? We have to say SOUT already sorted linked list, and then we can also do the print method, print head one or something, no problem. And then we can say return statement. Okay. Let's try again with the same inputs. If I say 5, then I say 1, 2, 3, 4, 5. It is already sorted linked list. Okay. If I run once more, and this time I give some elements, so if I give 8, I say 1, 2, 3, 4, 5. Then I say 8, 7, 6. Okay. Oh, got in some other issue. We'll just. So the mistake over here is that we have to put dummy dot next equal to h1. Okay, I hope you understand the issue. And then similarly, dummy dot next equal to h2. So this should work now. Let's see. 8, 1, 2, 3, 4, 5, 8, 7, 6. It works perfectly fine. So over here जो हमने कोड लिखा है, ऐसे लिखते वक्त आपको भी गलती आ सकती है. So you have to be sure and you have the ability to debug because there's a lot of lines. I'll show you. This program is of lines, 125 lines, ठीक है? And this 125 lines can be reduced by some spaces and all which I have put over there. But ठीक है, on an average, it's going more than 100 lines. Okay, बहुत बड़ा code है and then mistakes are obvious, but you should have the ability to solve them. ठीक है? Now the thing is, the code I have written over here is for linked list, singly linked list. So how can we convert into doubly linked list? This is the program. I'll show you the differences very clearly. Okay. So we'll see line by line what are the differences. Okay. So the first thing is that in linear linked list, that is single linked list, we don't have a previous pointer. तो previous pointer added हो रहे हैं. For simplicity, I'll just do this thing which highlight. Okay. Now the previous pointer is hidden over there. Okay. Next, the previous comes in the constructor also. Okay. Now in the reverse function, we had only 3 lines of check over here. But over here we have 4 lines of check. That is, we have added one more line that is for previous. So after saying head.next.next equal to head, okay. So what we have to do, we have to say that head.previous equal to head.next. Okay. Coming forward, over here in the merge function again, after dummy.next, we have to say head.previous equal to dummy, because when we are saying dummy.next is something, wait a second, yes, when you're saying dummy.next is something, then something.previous equal to dummy, right? To make the forward and backward links. Similarly, we are doing over here and everything in the merge function. ऐसे करना है. Okay. Let's move ahead. The print linked list. There's no issue at all because in doubly linked list we have next pointer also, previous pointer also. तो फॉरवर्ड ट्रैक करना है तो ऐसे कर देंगे. बैकवर्ड ट्रैक करना है तो क्या करेंगे? यहाँ पे एक टेल हमें ट्रैक करना होगा एंड देन जैसे वो टेल पॉइंटर मिल जाएगा तो उसके करस्पॉन्डिंग हम प्रीवियस ट्रैक करते हुए नल तक चलेंगे. सेम थिंग एज वी डिड हेड नॉट इक्वल टू नल, सेम वी विल डू फॉर टेल नॉट इक्वल टू नल. बट फॉर सिंप्लिसिटी एंड फॉर यूजुअल पर्पस हमें फॉरवर्ड ट्रैक करके प्रिंट करना होता है, इसलिए हम ऐसे ही कंसिडर करते हैं. ओके. Coming forward in the main method. ठीक है. Let's see what's the difference. The first difference is that in the for loop we have added this link. तो सही बात है. When we say dummy dot next is no, then we have to say the node dot previous is dummy. Okay. Coming forward, we took head one, t, temporary variable, first and second, something like that. Okay. All is well. And the next thing what we did that over here when we said first dot next equal to null, तो हमने फर्स्ट के आगे का तो नल कर दिया लेकिन सेकंड जो है अभी भी प्रीवियस को पॉइंट करता है जो कि फर्स्ट है. तो वी हैव टू से दैट आल्सो एज नल टू टेक द कनेक्शन एंड देन सिंपली वी कॉल द रिवर्स लिस्ट merge function and answer. ठीक है. Output will come same, but whenever say in case this has come in a company and they have restricted the main method or something like that, so and they ask you supposedly to print the elements from previous point of view, तो थोड़े बहुत चेंजेस करने पड़ेंगे आपको. ओके. एंड इफ सपोजिंगली दिस इज अ रिटन एग्जाम, ओके, एंड दे चेक लाइन बाय लाइन दैट यू हैव कंसीडर्ड प्रीवियस एट एवरी स्टेप, तो आपको पता होना चाहिए व्हाट आर द डिफरेंसेस एंड हाउ वी हैव टू मैनिपुलेट. सो फाइनली दिस इज द कोड दैट वी विल बी यूजिंग इफ द प्रॉब्लम स्टेटमेंट इज सॉर्ट अ बाइटोनिक डबली लिंक्ड लिस्ट. ठीक है. टेक अ क्लास, एक बार देख लीजिए. क्रिएटेड नोड क्लास, इनर क्लास, रिवर्स फंक्शन, ओके, merge function, then print function for linked list, doubly linked list, forward tracking. ठीक है. The main method we took n elements, how many elements, n elements, then for loop, take n number of elements, created nodes, make the connections, next and previous. For for the garbage collection framework, easiness, we did sc.close. Okay. This option you may write, you may not write. ठीक है. Next, अपने हिसाब से from your own side, you can take any variable names to do such works. ठीक है. First, second, Bitonic to handle the edge cases. Okay. If there is only monolithic increasing, no monolithic decreasing, or vice versa. Okay. We're tracking to find the halves, breaking the halves if the half exists. If not exist, we simply say linked list is already sorted and they'll print. Then the step one is after finding the halves, two connections, left half, second half, we'll reverse the second half and then we'll merge the first and second half. Both. Finally, this will be having the resulted answer. Okay, so that's all for today. I hope it's very clear. Thank you.